The next item in Chapter 4 within this Data Step 2 information topic are if-then statements. This could be used to create a new variable or somehow group existing variables. So if-then statements have a great utility. So what we want to learn then is that within a data step, we can say if a condition is true, then it makes a variable assignment or otherwise has some sort of an action. They're closely related to if-then statements then are if-then-else statements. So the assignment is executed if the condition is met. If the condition is not met, then it's a different assignment. So the assignment up here without the else statement, so if the condition is met, then it will say assign x equal to a new number. And if it's not met, then it's just going to result as if there's a new variable in this assignment statement, that variable will be missing. So what's important for us to learn is how do we specify these conditions? That's not really, that part isn't really a new variable, but how we use that to create new variables can happen. And so we'll first talk about table 4.3, which just gives us some syntax options. There are other things we could also put as conditions on this in these if-then or if-then-else statements. But this will just get us started here, and then we'll look specifically at a fish data set example in table 4.4. So first, just some syntax for specifying these conditions. So equal. If x equals 5, easy enough. There's also a text equivalent, the EQ. It doesn't have to be uppercase, but remember, consistent with my notation in the rest of the book, SAS commands are uppercase, or SAS syntax. Not equal to, there's the caret and an equal sign. And so also here, think back to one of the objectives done in the previous video or for earlier in this chapter. Whenever we had state equals Oklahoma, it was whenever we want to specify text as the value of the variable, that text has to be in quotation marks, either double quotes or single quotes. So the same thing here. So if color is equal to red or not equals red is indicated here. So you could use either double quotes or single, just so long as they occur as a pair. Strictly less than is the symbol we would anticipate just from an algebra class, or you can use LT. Less than or equal to. So these are, and then greater than and greater than or equal to. So all those are fairly self-explanatory. So this is just a sample for variables you could have. Inclusion in a group. This is if you have a large list, and so if time is in this set of values. So if this is sort of saying if time is equal to 3 or time equals 6 or time equals 9. Notice the comma punctuation in between each of the possible values for time. The group here doesn't have to be just numeric, so we could have if city is in the group listed here in parentheses, and because these are text, they are in quotation marks. Now remember, within quotation marks, that's case sensitive. So if the data for values of city were written and they were all uppercase, remember this proper case for Omaha then would not be correct. Also going back up here, if it's lowercase r instead of uppercase r, then that condition is never met. So you want to be really careful when you look at character variables so that you get that text exactly right. Logical or. So when we write a logical or, that means either one or both of these must be true. So here they're both equal to x, so x strictly less than 3 or x greater than or equal to 7. Now there's no value for x that satisfies both of those conditions. So it's either, in this instance, it's either going to be less than 3 or greater than or equal to 7. They both cannot happen. Okay, in this particular illustration. There are some illustrations where they could. Now, here I put in the illustration x is in both places. It doesn't have to be x in both places or the same variable in both places. Perhaps it could be x is strictly less than 3 or z is greater than or equal to 7. It could have been another variable. They don't have to be the same. Logical and means then that both of these things must be true. Okay, so if I look at y greater than 12 and another variable t is not equal to 13, both of those must be true for the condition to be satisfied. Now in the above illustration, if this or would have been an and, there is no value for any number but here x. X can never be both less than 3 and greater than or equal to 7. So that's going to make sure that you're attentive to what it means by a logical or and logical and. Both of these must be true in order for the condition to be met. Either or here is true. So that I could show you multiple if-then statements, I'm doing this with the data set fish, but I'm not actually putting this in one of the objectives at this time because there's so many if-then statements here. It actually they wouldn't all run on a data set this size likely, but we'll just keep it simple here. So the first part of this, our data and our input statements are just like we've seen in the previous objectives, most recently objective 4.5. And so we input the ID, location, the length in millimeters, weight, age, gender. We had a conversion to length in inches. We did the correction for gender. We included the state variable. Here's a new variable equals text. Location is proper case. So then both the low case and the proper case here were correcting data entry errors. So after the input statement and before data lines are where we're also going to place these if-then statements. So notice our data line statement, well, it's just down here, there we go, right at the bottom of the screen. Okay, so all of our if-then statements, I've got 3 different examples here of how you can do this. And so first I have an if-then and an else statement. That's a set of 2 horizontal lines put in here are for the purposes of the illustration to show you that these 2 things go together. So you would want to put the else statement immediately following the if statement. It could be on the same line. Here I've got them on separate lines, but just so long as they're both punctuated with semicolons. So here it's if length is less than 60, then size is equal to small. So a few things here first. If this condition is met, this is our original length in millimeters. If it's less than 60, then size. Size is a new variable. It was nowhere in the previous lines of the data step. Size is a new variable, so this is what we say we're initializing the variable here. And so capital S, then when we initialize that, that means that any further usage of the variable size will always appear in this proper case since this is its initialization. Now since size is a text value, then it's equal to small, and I've got that in single quotations. It could be in double, and this is going to be case sensitive. Then for else, if this is not true, so therefore for lengths greater than or equal to 60, size is equal to large. Size has already been initiated here, so I don't have to follow that uppercase, lowercase convention in later usages of the variable size. Now the value of the variable, the value that the variable size takes is large. It's a character string, and so therefore that is case sensitive. And again, this could have been specified within single or double quotes. So brief explanations are over here on the side. These aren't part of the SAS syntax. It's just telling you that's what these things are doing. In a second example, we could work with the variable age. So if age is less than or equal to 2, we're going to assign it to group 1. If it's greater than 2, but strictly less than 3, so notice less than or equal to 2, and then 2 is not included here. 3 is not included here. So if it's between 2 and 3, but not including the endpoints, it's going to be assigned to group 2. And for anything that is greater than or equal to 3 in age, it's going to be in group 3. So with the else statement, you could catch anything from when this condition isn't satisfied. Here you can have multiple if-then statements such as this, and these conditions on age encompass all of the possible values for age, so an else statement wasn't needed here. Now could you have put 1, 2, and 3 in quotation marks? that's kind of off script here from the book, but surely we could have done that. Okay, that's going to create text, and in this instance they're groups, and so those are going to be nominal variables for us, or actually probably ordinal at that. If we want groups 1, 2, and 3, if the ascending groups number is going to be indicative of older age groups. Okay, but we could have put them in quotation marks. We lose the ability to do any computation on a variable when we do that. Except since these are ordinal at most, then we really wouldn't want to average those. I can't think of an implication where we would. Also notice when group was initialized, it's always going to appear as lowercase everything in the output, because when I initialized it in this first if-then statement, it's lowercase g. If location equals Payne, then Lake equals Carl Black. Whoop. Sorry, I let that slip here for our local participants. Lake equals CB. Okay, that's in quotation marks. Lake is initialized and it's all lowercase. If I want it to be proper case for usages in a report, and so I don't have to edit it when I export it to a report, then I probably want to make a capital L there. All right, if location equals Payne. Because the data are case sensitive, then Lake is going to be missing everywhere. Because remember, we corrected location up here. Location is proper case of the location. So up here, remember we had locations. Some of those locations were spelled out as with capital P for Payne, and one with lowercase for Payne. So as soon as I correct it up here, this is never true. Okay, because all of our data are case sensitive, Lake is going to be missing for all of the observations. We should have used an uppercase P for Payne. That would have worked. Okay, if we would not have done this, this statement down here would have only worked for one of our observations, because one of our observations had lowercase p. But as it is, we did the proper case, we corrected that. That's up here at the top of the screen. And so that's one of the reasons why we didn't execute all of these. If you wanted to see the effects of these if-then statements, then you could follow up this particular program with a print procedure. Two other if-then statements that are also quite useful is if condition, then delete. So when the condition is satisfied, then delete. I'm really reluctant to tell people to delete data. Usually there are some other ways we can control a data set for what elements go into it. So you just want to be really careful if you use such a statement, if then delete, that you are not ever indeed going to need that data once you've deleted it. Okay, so you want to be very careful there with this choice. So whenever that condition is met, all of those observations will be deleted from the SAS data set. If condition, and we don't put a then but just a semicolon, so what this does is it retains those observations or rows of data that satisfy that condition. So just be absolutely certain. Those are two kinds of extremes. Just be absolutely certain that that's what you want to do. Okay, the next statement is a where statement. Not really a data step statement, because we've seen in previous syntax for univariate procedure and the means procedure, recall that there was an optional statement there. There was a by statement and also a where statement. Both of those are optional. By statements required that we sort the data. The where statement requires us to be able to specify this condition. So the reason I include the where statement here is because it requires us to know that syntax for specifying the condition, and we just learned that in the if-then statement, which most definitely is a part of the data step. If-then does not work in a procedure, only in a data step. The where statement works in the procedures. So we specify the condition where this condition is true. Okay, so we can say where x is less than 5, where location equals pain, whatever it happens to be, we can use that condition. So if you go back and review those procedures in the earlier chapters, there's a where statement in there that's an optional statement. And so we can look at how to use the where statement in the next objective. So in objective 4.6, we work with the fish data set again. And so I still have the length in inches, the correction on gender, the addition of the state variable, and the correction on the location to proper case. So that's the modification we left off with in 4.5. We have all of our data read in. So if we want to only print a list of those observations where weight satisfies this condition, where weight is less than or equal to 15. So weight, recall, is going to be after the column after length. So whenever weight is less than or equal to 15, and notice I've got 2 lines of title to help me identify that. Or we could look at a procedure such as the means procedure and just ask it to operate on variables here, length in inches, and weight for only the males, lowercase m. So notice I did lowercase on gender. Okay, so if we run this or submit this program, we see that we have a print procedure for objective 4.6, a means procedure for objective 4.6. So over here in the results viewer, the observation numbers printed, they were the 3rd and the 4th observations in the data set. It kept that observation number and gives us the information here where weight is less than or equal to 15. Weight 12, weight 14. Now this is a small enough data set we can go back and check. So I have 24, 16, too big. The 3rd and the 4th ones, observations in the fish data set are the 2 that were printed. The others all have weights in excess of 15. So you can see then that we can keep this entire data set intact and just have a procedure operate on only part of it. Likewise, we could look at the means for both genders, but if we only wish to recover it for one, then we can use the gender equals m, lowercase m here. And so up here we have 1, 2 that observations in that. When we do the summary statistics for the males, you see that we have the n equals 2. The other thing we did was we only operated on 3 of the variables, length in inches, and weight. And so those are the 3 variables then that were analyzed, 2 observations each. And so we get the default output from the means procedure for those 3 variables for the males only. Now, whenever you use the where statement for where where gender equals male, notice I don't get a delimiter like we saw with the by statement where we had gender equals female, gender equals male, and we had those 2 tables. So when I use a where statement, I don't get that extra piece of information printed on the procedure unless I choose to do it myself in a title. Likewise, for the weight being less than or equal to 15, there's nothing at the top of that list that tells me that's what's going to happen unless I insert that title.